So my part is I want to tell about the type of turbine. There are many type of turbine they have, but I will talk about three of them, which is Kaplan turbine, Francis turbine, and Pelton turbine. So the first thing I want to tell is the basic construction. A turbine is a device that harnesses the kinetic energy of some fluid, such as water, steam, air, or combustion gas, and turn this into the rotational motion of the device itself. These devices are generally used in electrical generation, engines, and propulsion system, and are classified as a type of engine. Turbines are used in many different areas, and each type of turbine has a slightly different construction to perform its job properly. Turbines are used in wind power, hydropower, in heat engines, and for propulsion. Turbines are especially important because of the fact that nearly all electricity is generated by them. Okay, so next I will show the picture of the example of Kaplan turbine, Francis turbine, and Pelton turbine. After I show you the basic construction of the three type of turbine, which is Kaplan, Francis, and Pelton, now I will show the example of basic circuit for the three type of turbine, which is I tell you Kaplan turbine, Francis turbine, and Pelton turbine. That is the basic circuit of the three type of turbine. So next I will tell you the principle of operation of the turbine. So the principle of the operation is the working principle is very much simple, which is when the fluid strikes the blades are displaced, which produce rotational energy when the turbine shaft is directly coupled to an electrical energy. This electrical power is known as hydroelectric power. Okay, now I will tell you the characteristic of the turbine, the type of turbine. For the characteristic, I will explain about by the curve for the turbine. So the characteristic is curve are drawn by conducting experiment at constant heat, and the second, head and gate openings are kept constant and speed is varied by varying load on the turbine. So the characteristic is for each value of speed is based on the speed corresponding value of power, and discharge are obtained. So this is the characteristic which can affect the curve of the turbine, of the output of the example of the turbine. Okay, so next I will tell you about the application. So for the application, I will tell to you by one by one from Kaplan turbines, and then Francis turbine, and the last is Pelton turbines. Kaplan turbines are widely used throughout the world for electrical power production. They cover the lowest head hydro site and especially suit for high flow condition. Independent micro turbine on the Kaplan turbine model are manufactured for individual power production with as little as 2 feet of head. Large Kaplan turbines are individually designed for each site to operate the highest possible efficiency, typically over 90%. They are very expensive to design, manufacture, and install, but operate for decades, which is Kaplan turbine is a high cost and to build the design, manufacture, and install. But if the Kaplan turbine is get, which can use for decade, it's a very long term. So next Francis turbine. Francis turbine is Francis type. Units cover a head range from 40 to 900 meter, which is in the term of feet is 130 to 20,000 feet. Its efficiency decreases as flow decrease. They may also be used for pump storage, where a reservoir is filled by the turbine, acting as a pump. driven by the generator acting as a large electrical motor during periods of low power demand. So for the Francis turbine, the name of Francis turbine is because the design is look like Francis type. So is the range of the feet is quite big. So the lastly is the Pelton turbines. Pelton turbines is Pelton wheels are the preferred turbine for hydropower. So the Pelton turbines is for hydropower when the available water source has relatively high hydraulic heat at low flow rates. Pelton wheels are made in all sizes. So Pelton turbines is made in so many size and all size. You can get a Pelton turbines in many size for maximum power and efficiency. The wheel and turbine system is designed such that the water jet velocity is twice the velocity of the rotating bucket. So you can see here that I tell the water jet velocity is twice the velocity of rotation bucket. They exist in multi-on Pelton wheels mounted on vertical oil pad bearing in hydroelectric power. Okay, that's all for the application of the turbine. So the last thing that I want to tell you about the advantages and disadvantages of the turbine. So for the advantages and disadvantages, I will tell you is one by one from Kaplan, Francis, and Pelton. The advantages of the three types and the disadvantages also. So I will tell about the Kaplan turbine first. So the advantage of Kaplan turbines is even in low water speed, it still permits a high rate of blade rotation. So this is a good because when the low water speed, Kaplan turbine is still can permit a high rate of blade rotation. So this is very good. So but the disadvantages is they are very expensive to design and construct. So I can tell you this is a very high cost to design and construct the turbine. But if you can build the Kaplan turbine, this can use a very long term and even a decade. So next I will tell you about Francis turbine. Francis turbine is a variation in operating head can be more simply controlled. Okay, you can see that Francis turbine variation in operating head can be more simply controlled. So for the newbie or a new guy want to try the turbine is Francis turbine is more easy to control. Okay, next, no head failure occurs still at low discharge of water. So we can do discharge of water. So the disadvantage, the water which is not dirt free can cause a very rapid wear in high head Francis turbine. So current losses are certain. So the disadvantage of Francis turbine is current losses are certain. So it's not good, but still can use. Okay, the lastly is a Pelton turbine. Pelton turbine, it has a very simple construction, and also it is easy to maintain and it can work on low discharge. So the advantages is very easy to use and can easy to get the Pelton turbine, and so we can work on low discharge. Okay, so but this disadvantage is turbine its size is generally large. So the Pelton turbine is generally have a big size or large size, so you can a little bit hard to use. So and its efficiency decrease quickly with time. So its efficiency is decreased quickly with time. So if you use the Pelton turbine in the long term, so the efficiency is decrease. So it cannot use by the long term. It's a small term and only for maybe or a couple of months, and That's all for the disadvantages and the disadvantages for the type of turbine Kaplan, Francis and Pelton.
Assalamualaikum warahmatullahi wabarakatuh. I will explain about inverse time relay and directional relay in protection system. Okay, first we look at the basic construction. In electrical engineering, a protective relay is a relay device designed to trip a circuit breaker when a fault is detected. The first protective relay were electromagnetic device relying on coils operating on moving parts to provide detection of abnormal operating condition such as overcurrent, overvoltage, reverse power flow, overfrequency and underfrequency. Okay, for the inverse time relay, the relay operation time is inversely proportional to the fault current. Inverse time relay are also referred to as inverse definite minimum time (IDMT) relay. Inverse definite minimum time, the operating time of an overcurrent relay can be moved up, made slower by adjusting the time dial setting. Okay, for the directional relay. Directional relay is a relay use an additional polarizing source of voltage or current to determine the direction of a fault. Direction element respond to the phase shift between a polarizing quantity and an operate quantity. Okay, this is the basic construction of the relay. Okay, next we look at the basic circuit. Okay, this is the basic circuit of a inverse time relay and a directional relay. Next, principle of operation. Okay, for directional relay, the fault current can flow in both the direction through the relay, either forward or reverse, depending upon fault location. Therefore, it is necessary to make the relay respond for a particular defined direction, so that proper discrimination is possible. This can be achieved by introduction of directional control element during the opposite flow of current, the CT polarity reverse. The power measuring device in which the system voltage is used as reference for establishing the relative pace of the fault current. Okay, operation for inverse time relay is the time of operation depends upon the magnitude of actuating quantity. If the magnitude of actuating quantity is very high, the relay operation is very fast. In other words, the relay operating time, that is time delay in the relay, is inversely proportional to the magnitude of actuating quantity. Okay, this is the characteristic for the inverse time relay. Okay, we look at the graph. When the actuating quantity is at OA, the operating time is of the relay is OA prime. When actuating quantity is OB, the relay operating time is OB prime. And when actuating quantity is OC, the relay operating quantity is OC prime. Actuating quantity less than OA, the relay does not at all actuate. So the mean is over here. Okay, the minimum value of actuating quantity for which a relay initiates its operation is known as pickup value. Okay, this is a pickup value, is the minimum value of actuating quantity. Okay, when actuating quantity approach to infinity along x-axis, the operating time does not approach to zero. Okay, this not approach to zero. Okay, next to the characteristic for directional relay. First, directional relay has a high speed operation, and then high sensitivity, advocate short time, then have a thermal rating. Next is ability to operate with low value of voltage, but then must not be excessive. And lastly is there should be no voltage and current creeps. I will explain about the application of inverse time relay and a directional relay. These two relay is used in motor protection, in transformer protection, inline protection, and distribution protection. Okay, next I will explain about the advantages and disadvantages of these two relay. Okay, first we explain about the advantages. This relay have fast operation and fast reset. It can be used for both AC and DC system for protection of AC and DC equipment. And the last advantage is have a property such as simple, robust, compact, and most reliable, and are almost instantaneous. Okay, disadvantages for these two relay is first, the directional feature is absent in electromagnetic relay, required periodic maintenance and testing unlike static relay. Okay, the last advantage is relay operation can be affected due to aging of the component and thus pollution resulting in spurious trips. Okay, that's all from me. Thank you.
Hi, Assalamualaikum. My name is Haniza Syedra binti Arman. My matric numbers is AA180332. We're talking about the three-phase transformers connection. Okay, firstly, the three-phase transformers is like the single-phase transformers. The working principle of the three-phase transformers are same as the single-phase transformer. Okay, we continue with the basic construction. The basic construction of three-phase transformers can divide by two. First is core type construction. The second type is shell type construction. Okay, the basic construction we can show in this figure. Okay, there is three legs. Or we call it as a limb. So as usual, the core laminate with the thin. The core is made up with the thin laminate sheet because it want to reduce the eddy current. Okay. Every leg has a primer and secondary winding in this cylindrical shape. So the figure as shown this is well to illustrate how the three-phase transformers core type construction. Okay, next we are talking about the shell type construction. Okay, as we can see in the shell type three-phase transformer, the three phase are more independent than they are in the core type. Each phase has its individual magnetic circuit. The construction of the shell type three-phase transformers is illustrated in the figure this. The construction is similar to that of three single-phase shell type transformers keep on the top of each other. The shell type construction are same with the it's not same, it's the similar to the core type transformers. Okay, next we are going to talking about the basic connection of the three-phase transformer. The basic connection of three-phase transformers is it has 5 connection. First, star-star connection. Second, delta-delta connection. Third is star-delta connection or two-way data connection. Okay, next open data, and then the lastly is the SCOT connection. Okay, the first one is star-star connection. We can see the star-star connection is generally used for small and high voltage transformers. The ratio on the primary side and the secondary side is equal to the transformation ratio of the transformer. It's used only if the connected load is balanced. Okay. Next, we are going to talk about the delta connection. Okay, the delta connection is generally used for large and low voltage transformers. It can be used even unbalanced loading. Okay, next we are going to talk about the star delta connection. The primary winding is connected in delta connection, while the secondary is connected in star with neutral grounded. The star delta connection mainly used in step-up transformers. Okay, next we have the open data connection. The open data connection can be used when one of the transformers in data bank is disabled, and the service is to be continued until the faulty transformer is repaired. The open data can be used for small three-phase loop. Okay, next, the SCOT connection. It used two transformers. One is main transformers, and the other one is the taser transformers. It can be used for three-phase to two-phase conversion. Okay, next we are going to talking about how the three-phase transformers operation. Okay, the principle of the operating transformers is only primary winding connected across the three-phase AC supply. It's arranged and angled at 120 degrees to each other. When the primary connected, the current start flowing through the phase winding and produce the magnetic flux. Fluxes induce the secondary EMF is respective phase until they maintain their phase angle between them. The EMF flow the current in the secondary and then to the load. Okay, next, the application of the three-phase transformers we can get at the three-phase oil field distribution transformers. Okay, this one is the three-phase oil field distribution. Okay, next, we can apply it in the electrical grid. Okay, and next, the power transformers. You can see this is the power transformers. Okay, the three-phase transformers has pros and cons too. The advantage of the three-phase transformers is, first, low cost. Second, high efficiency. Third, it easy to install. Fourth, less space to install. Also, it provide the same kVA. It's provide the same kVA, and it's only use 3 terminal required compared to 6 terminal from the 3 single phase transformers. If you use single phase transformers, you need 3 single phase transformers. So it means you need 6 terminal to install the transformers. Okay, the disadvantage of the three-phase transformers is, first, is required the high cost to repair. Okay, second, it's difficult to fix malfunction. Okay, next, if fault happen in any phase, you need to replacement the whole unit. Okay, and lastly, the capacity will reduce stimultaneously because it is self-cooled. Thank you. That's all from me.
Hello, Assalamualaikum. My name is Nik Muhammad Imam bin Nik Abdul Khalid, and I'm going to present my assignment. It is transmission line. So, for the introduction, a transmission line is used for the transmission of electrical power from generating substation to the various distribution units. It transmits the wave of voltage and current from one end to another. The transmission line is made up of a conductor having a uniform cross section along the line. So this is the basic construction of the transmission line. A transmission line have a transmitter and an antenna, and they have an input end and output end. And then this is the basic circuit of the transmission line. In the circuit, we can see they have a capacitor, resistor, and inductor. So the principle of transmission line is all transmission line have two ends. The end of a line connected to a source is ordinarily called the input end or the generator end. Other names given to this end are transmitter end, sending end, and source. The other end of the line is called the output end or receiving end. Other names given to the output end are load end and sink. The ratio of voltage to current at the input end is known as the input impedance or Zin. This is the impedance presented to the transmitter by the transmission line and its load. The antenna, the radio voltage to the current and the output. The output end is known as the output impedance Zout. This is the impedance presented to the load by the transmission line and its source. If an infinitely long transmission line could be used, the ratio of voltage to current at any point on that transmission line would some particular value of impedance. This impedance is known as the characteristic impedance. For the application, the transmission line is used for telephone, for cable TV, CATV or community antenna television. Then transmission line also used for broadband network. After that, they also being used for high frequency circuit like circuit for board RF circuit, and in microwave application such as radar system, global positioning system or GPS. Then I'm gonna show you the advantages and disadvantages for the transmission line. For overhead transmission line, the advantages is they have high power transmission and low installation and material cost. They also can make a long distance transmission. The fault or damage in overhead line can easily locate. The maintenance of the line is easier, and also the extension or joining on overhead line can be performed easily, and also is facilitates easy replacing. For the disadvantages, it is exposed to the surrounding and the safety risk is high. Next, a continuous pathway for the line create obstruction, and it is vulnerable to lightning strike. And for the underground transmission line, the advantages is the underground transmission system are safer than the overhead transmission system. It safe from lightning and it create no obstruction. And for the disadvantages, the installation process through various geographic area has high difficulties because of ground excavation. Then the installation cost of underground transmission is high as it requires a continuous trench or concrete duct for cable installation. Also, it has a high material cost due to the requirement of thick and insulated conductor. The underground transmission system have high cost of maintenance because the line need to dig up before any repair activities and required to reinstall again. Higher complication in fault defection and maintenance, and high voltage transmission is difficult in underground transmission. And lastly, it is limited by thermal capacity. So that's my presentation for transmission.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amalia Atira binti Muhammad Azman, and I will present about earthing system. So for introduction, earthing or grounding system connects specific parts of the installation with the Earth's conductive surface for safety and functional purpose. Also, earthing is a method of transmitting the instant electricity discharged directly to the ground through resistant wires or electrical cable. Earthing system has three types. First is TN, transformer neutral earth, frame connected to neutral. TT, transformer neutral earth and frame earth. IT, unearthed, transformer neutral earth frame. Okay, next for basic construction. Earthing system consists of conductive earthing electrode that connecting to each other, and earthing line and earthing concentration line being positioned between the electrical equipment and the earthing electrode. Okay, for system earth electrode number 4, it is function as serve to earth one point of the operating circuit, while protective earthing electrode serve to earth conductive part of the system. So for transferring electrical current from this into the ground, all conductors are sued which have well-conductive connection to the ground. Earthing electrodes are either dug into, driven into, or placed in borehole in the ground to complete an earthing system. Ground is made of the soil. This one. Okay, next for basic circuit of earthing system. And for the diagram, when the fault occurs, the fault current from the equipment flow through the earthing system to the earth and automatically protect the equipment from fault current to prevent an electric shock for what touch it. So when the live wire and neutral wire bring a current, and when fault current pass through earthing, it will flow through earthing electrode, which save the equipment from electrical shock. Okay, next, related circuit for TN system. By the way, TN system has three variants such as TNS, TNC, and TNCS. Okay, for TNS is a separate protective earth, PE, and neutral conductor from transformer to consuming device which are not connected together at any point after the building distribution point. Next, for TNC, it's a combination of PE and N, so it's become PEN. This conductor all the way transformers to the consumer device. Next is TNCS system. It's a combination of PEN, so we can see PE and N, conductor from transformer to the building distribution point, but it's a separate PE and N, which is it's separate conductor in fixed indoor wiring and flexible power cords. And next, this is related circuit for TT system. And for TT system, the protective earth connection for the consumer is provided by local earth electrode and another independently installed at generator. There is no wires between the two. Next, related circuit for IT system. The electrical distribution system has no connection to earth at all. You can see for the earth is no connection to earth at all, or it has only a high impedance connection, but it's a simple installation because it just put earth there. And next, for principle of operation earthing system, the potential of neutral is held at earth potential. The fault current lags behind the voltage of LT line by 19 degrees due to predominantly inductive nature of circuit. So the current through neutral in phase opposition to capacitive ground current. Neutralization of capacitive ground current earthing ground is eliminated. So for ground fault in line B, vectorial sum current measured by CBCT non-zero. When sum is non-zero and there will be flow current through neutral, has to be distinguished for being due to ground fault or due to small unbalance. To make differentiation, we employ PE. So we install a PE there. The path of fault current complete through this conductor, providing low impedance. So next, For characteristic of RT system is divided to 3 variants. And for TT system is have a simple solution to design and install and be used in installation supplied directly by public distribution network, and it does not require continuous monitoring during operation. Then protection of system ensured by residual current device we call RCD. And for RTN system, it requires installation of earth electrode at regular interval through the installation, and it also requires initial check on effective tripping for the first installation. Next is require any modification or extension be designed and carried out by qualified electrician. For IT system, it has best continuity of service during operation. Next is require maintenance personnel for monitoring and operation. Then it require high level insulation in network to prevent high leakage current. And for application, IT system, it's used in laboratory room, medical facilities, construction site, repair workshop, mobile electrical installation, and other environment that supply with engine generator where can increase risk of installation fault. IT system is used because of its cost. The cost is cheap. Next for TT system, it's been used in remote areas or in rural areas that threatened by the fracture of an overhead. So for TNS system, it being used in low tension supply (LT) supply in India because of neutral is double grounded at each distribution transformer. Neutral and earth conductor run separately on overhead distribution line. Separate conductor for overhead lines and M-ring of cable are used for earth connection. Additional earth electrode or pins are installed at each user and to provide redundant path to earth. Next for advantage, earthing system offer a low value to current flow for line to line ground fault. The value is 5 ampere or less. So for TN system, it always provide a return path for valves in the low voltage grid because grounding conductor at transformer and at all customer are interconnected, so it will ensure a distribute grounding and reduce the risk of customer not having a safe ground. So next system is work with simple overcurrent protection and it have high reliability of disconnection of fault by over. For TT system, the advantage is it has good security condition. As the potential rise of the ground conductive part must be limited of 50 volt for a fault inside the installation and at 0 volt for a fault on the network. It also has simple earthing installation and easiest to implement. TT earthing system also no influence of extending the network. And for IT system, it increase ability of installation because with IT system installation for the current cannot be looped Through the transformer neutral, so the first fault current value remain very low. And IT system increase lifespan of equipment due to very limited fault current in IT system. Next, for disadvantage of IT system is it has probability of safety hazard is high because of incomplete insulation from earth that will produce a shock because there is no path for the shock current to return to the circuit if the supply earth connection is not made. And for TN system, fault in the electrical network at a higher voltage level may migrate into the low voltage grid, grounding, and it cause touch voltage at low voltage customers. And next, it increase fault load impedance if the protection not to be fit in case of network modification. For DT system, it needs to install and maintain on ground electrode, so the reliability is not assured. Next, high over voltage may occur between all live part and protecting of conductor that can cause over voltage stress on equipment insulation after installation. Last, for IT system, it should not be too large because when it becomes complex, it will have an undesirably high system leakage capacitance. Then, it could increase a voltage in the event of insulation fault. This happens because in an IT system with an insulation fault on one conductor, the line to line voltage on the other conductor increase in relation to the earth potential. So, this is from me. Thank you.